Recording. There you go. Now it's working. Recording and transcription, hopefully. All right, now I'm going to share the screen. And share the screen, share the screen. That's the one that we want to share. And hopefully it's going, and you see 2 minutes and 12 seconds to record. That's fantastic. Okay, so we are approximately 15 minutes late, but hey, better than nothing, right? Okay, so let me bring up what we had before and quickly go through it. And then we're going to talk about classes with resources. That's a very short thing to talk about. It's not very difficult, actually. We see noticeable amount of people who are not here for some reason. I don't know why, but we'll see. But there is no YouTube video for this, so I have to kind of download the video and upload it to YouTube later on somehow from Microsoft Teams. If anybody knows how to do that, let me know. I have to figure it out. Yeah, so I'm going to open the things that we've talked about last time, quickly go through it, which is here. We talked about, we kind of finalized all the operator overloads. I think that was the last one, right? Let me just double check and see what we had over here. Yes, all different types of operator overloading we have done, and we have it. We created a string, and sorry for the colors. This is not my colors usually. If you're not used to it, I don't know how to change the theme of this one. If anybody knows, please let me know. To dark, but this is hopefully good. Is it okay? Too bright? Okay, so do you know how to change it to dark? Anybody know? I don't know. Oh, wait a minute. I forgot. I can ask my friend. Where is ChatGPT? Chat. Huh? Tools options. Thank you. Okay, tools options. Okay. Environment. I am in environment. And color? Dark. Okay.
That looks like
Anybody knows how to get rid of, well, forget it. I just was that. I hate that. That's very good when you're writing 90,000 lines of code, but when you have 3 lines of code, that's. I don't think so. It's just up and down. Okay, forget it. Doesn't matter. Okay, so we created different types of operator overloads. We talked about read and display, and we talked about that to see actually how we can actually create a specific type of operators created. We had the string, for example, over there. Then what is this? These are the STRs that we have. That are our library. Maybe I'm going to use it today. We created the bottle thingy and we displayed of it. So yeah, so essentially we went through all different types of overloading the last time that we were here, right? Now, today we are going to talk about the consequences of dynamic memory allocation, okay? And see how we can actually make our program, our class, when it has dynamic memory allocation, take care of itself when the objects are being copied. And for that, I need to actually show you something before we continue. So let me see if I can actually find the PowerPoint presentation that I had about copying in my notes, and hopefully we have Outlook over here, sorry, a PowerPoint that I can show. So let me just do a search. PowerPoint TX, I think these are the ones. There we go. Bad copying, good copying. There we go. I found these two. So let's get this one and this one and this one and this one. Copy that. And I'm going to bring it to today's lecture, which is here. So right click over here. Add existing item. And in here, I'm just going to paste it. No. Cancel. Copy. And right click, paste. Cancel. Okay, what's going on here? Give me a second. These are the, okay, let me just open file location, hopefully. Open file location. Yeah. My apologies, acting kind of strange. Okay. Open file location. Okay. This is good. Okay, I'm gonna just copy everything and bring it here. Now it's good. All right. So let me open it up and see if I can actually show you what's going on and why we needed today's lecture. So open folder. Quickly. Yes. Okay. So we talked about dynamic memory allocation. I'm quickly going to go through the things to kind of remind you of what we talked about. We said when we have a regular allocation, statically allocated memory, everything that you have is inside your executable. But when we have dynamic memory allocation, we have one pointer and our memory is outside of our executable somewhere in heap. And because we created it, we are responsible to wipe it out. That's what we said, right? Remember that? Okay. Next thing was, and I'm so happy that the PowerPoint works. We talked about dynamic memory allocation, and we said dynamic memory allocation requires serious precautions, which means when you have a pointer, that pointer must be initialized and used properly. If you just create a pointer and use it, you're going to go to some address that doesn't belong to you. You have to always keep the pointers as null. You have to make sure that you are not going out of the range. You always stay within the boundaries of your dynamic memory allocation. And when you you have to make sure that when you are assigning the pointer to another piece of memory, you take care of the old one. Because if you just do that, you're going to have memory leak. The other piece remains orphan, and it's not going to go away until you restart your computer. And that's your memory leak. So we set the correct state of an unused memory. Yes. No, restart the computers. Yeah, yeah. Pardon me? Because it's in the heap. It's a place that all the programs are being used. But if you are running it under Visual Studio, no. Because Visual Studio simulates everything when you are debugged. See, at the top of Visual Studio, that was a beautiful question and requires the answer. So in Visual Studio, if you see over here, it says debug. If you are going to production that is release, no. But when you are in debug mode, everything is simulated, even the memory. So it simulates an operating system and a program running. So when you are actually doing dynamic memory allocation, it does it within the debugging environment. And when the program ends, it throws it away. But if you go to release mode, then the story is completely different. Okay? Does that make sense? All right. So yeah, so we said the correct state of unused memory is to always set it to null. And if you are using a logic that keeps track of the size, is to keep the size as 0 when you are not using memory. But when you are allocating memory, you need to keep track of the size and exactly know how much memory you have. And when you delete, you have to delete the way you created it. If you create an array, you delete it like an array. You have to always set everything back when you are deleting. So again, set the data to null and 0. Now, we are at the stage that we have done a little bit of this. So don't play as a rookie, which means when you are in the destructor and you're deleting something, don't set it to null afterwards. It doesn't make sense. If you have that code and representing yourself with that code in an interview, if somebody sees you are setting the stuff to null in a destructor, they know you have no idea what a destructor is. So it's misrepresentation. So if you expect that 1 in a million, that pointer is going to be used again, set it to null to make sure you flag it to empty. But if you're in a destructor and the destructor is supposed to destroy the object, then who cares if the pointer that is going to get wiped out and destroyed is null or not? It's like after he's finishing his coffee, he goes and washes it clean and then throw it in garbage. You don't do that. You just throw it in garbage. That's why it's we're good. Okay. That's that one. Correct way of deleting is important. If you forget, if you miss that square brackets when you allocate it as dynamic, it only deletes the first element, and therefore you're going to have memory leak. And when you are reusing the pointer, always make sure that your the memory is not actually being used. So for deleting, you don't need to check for null to delete. What I'm saying is that if you are reassigning it, make sure if there is any unfinished business with the data, you do it and then you delete it. If you delete, you don't need to check for null. If it's a null and you're deleting, nothing's going to happen. That if statement is written inside your delete. Okay? But make sure you take care of it before you do it, and then you reuse your memory. Again, always remain within your range and you'll be fine. So down to this point, we talked about dynamic memory allocation. What? Problem is not that. And actually, we talked about memory resizing too. And we said whenever you want to do memory resizing, what you need to do, you need to always have a temporary pointer to resize memory. You cannot just do it like that. You have to have a temporary piece of temporary pointer, allocate the desired memory that you want in that pointer, move all the data to the new location. After doing that, then you can delete the old one. And after deleting the old one, then you update and it's gone, then you update the size. And when the size is updated, now you are ready to make your pointer point to the actual data. Okay, and when you do that, when the process is over, that temporary variable you had in your resizing procedure will vanish, and what is remaining is the data with new size. We good with that? Are we okay with that? Yes.
Size can never be updated on the place. It has to be like new and the new size.
Yes.
Always.
Always. That's how it is. You can, it's like this. You can always rent a place from operating system. You can never ask the operating system to rebuild something for you. It's like when you are going to a place, I want this room that is small or this room that is big. You cannot go to a hotel and say, could you please demolish the walls and make it bigger for me? You can't do that. And that's why you always get the amount that you want. Or if you want a smaller place, it's the exact same thing. You make it small, you copy only pieces of it, and the rest will go to garbage and so on and so forth. But you always need a new piece of memory. Remember this that I'm talking about today. In OOP244, this is going to come back to haunt you. Okay? When we are going to standard template libraries, there are things that do all these things automatically. For you to write an efficient code, you need to remember this moment, what he said, that whenever you want to resize the memory, you need to get the entire new thing, copy everything, and delete the old one. So if you have 1 million bytes of memory and you want to make it 1,000,001, your memory needs to have 2,000,001 bytes. To make a 1,000,001, copy the 1,000,000 bytes, delete the old one. Remember that, okay? Okay, so that's that. Now that we know all these things with resizing and stuff like that, we're going to come to our object orientation, which we actually have a class that has some data in it. So we created a string over here, right? String is actually a very good example for this. Let's do that. And we're going to write the entire thing out. So I'm going to actually adopt what we have over here. So let me just do this. I'm going to bring the string over here and the strh and cpp over here, and we're going to teach the rest of the stuff using the string we started. We good? Okay. So let me go back, open. So this is the place, and in here I have string.h.cpp, this and that. Copy all those beautiful stuff, copy, close it. Then I'm going to say right click, add existing item. And in here, I'm going to paste all those good stuff, and I'm going to say add. So now I have string.h and all the good stuff that I have. So let me take a look at the code and see what can stay and what can be gone in here. Oh, shoot. Okay, now it's going to keep telling me what is new and what is old. Okay, let's close all the tabs and start with these. So I have string.h and I have all these good stuff. I have the constructor and I do not have a destructor in string.cp. I'm just looking at the code quickly to see what do we have. Yeah, all gone. We'll implement it later. That's the amount of difference that you have with, we have the old source code, so I'm going to bring it and modify it. Okay. So I'm just going to, not to clutter what we have, what we are supposed to do over here. I'm just going to wipe this out completely, except for the display. Let it be. Delete, delete, delete. Yeah, except for the display. So let's let that go. And I'm going to wipe everything off in here and just start new. So now we have a string that it has data, but I don't want it to be limited to a certain amount of bytes. So what I will do over here, I'm going to say the data of the string will be a pointer, dynamic memory allocation. So what I want to create over here is to get rid of arrays for strings. I want to have a variable to be able to set that variable to far.dat. And if I want to make that far.dat Solimandu, I want to be able to say name plus equal space. So it adds one space after, or name plus plus, that adds one space after. Then I'm going to say name plus equal Solimandu, then it becomes far.dat space. I want to be able to use a string like a variable. So to do that, I will create a dynamic string for me. Okay. So because I want it to be dynamic and I want to be fast, I am going to create should we do that? I'll do it. Probably I'm going to remove it afterwards, but for now, let it be. Okay. So I have this. Now I want to have a constructor for it. What did we say when something is not used? I'm going to say over here, I'm going to create string, and that string is the default constructor. Then I want to be able to create a string with a constant character pointer data, whatever it is, to be able to set it to that. So that's that one. Then I want to have a destructor. Why do I need to have a destructor? Because it's dynamic. When I dynamically allocate it, when I get out, I want to get wiped out properly. And I want to have a display, and I had a display. I'm going to bring that up because it was written properly, and I just need to modify it. So that's my display that I had over there, and it looks okay to me. The only thing I need to do over here is to check for the safe empty state. Okay, so how do I know if the string is empty and it doesn't have anything in it? If it's null or not. So one thing that is always good to do is to initialize these things right off the bat. This guarantees that no matter what type of constructor you have, those things are defaulted. The standard of empty curly bracket in front of anything nullifies it. So this becomes null, this becomes 0. We good? All right. So now our display, when it cannot display, when data is null, right? So all I need to do over here is saying, I can either say if mdata and just display it. I can just do this. And I have no idea why is it giving me that. Incompatible. What is it incompatible? Why is it? Oh, this is O string. This is STD, you bad boy. Okay, that's better. What do we have here? That's good. All right. And in here, I need to use it. So we're good. Questions down to this point? I just made the boo-boo and I fixed my boo-boo. Okay, so let's split the window in two so we can see what I'll be doing. What we are doing. Okay. All right. So that's why I don't like those two things. Just anybody knows quickly how to close these things? No. No. You pay attention, please. Control Shift P. Control Shift P. No.
Search for, you can search for the code and type.
What did you say? 1%.
Control Shift P, then you're gonna type minimum.
Okay. Then should I call? Did I toggle what?
Yeah, minimum.
Minimal?
Map.
It's called minimap?
Yeah, minimum.
Toggle. That's called minimap. Toggle the comment, spell check your code file outlining. So just minimap maybe. It's called minimap, are you sure? I don't know. That's okay. Never mind. Sorry, I have OCD. I have OCD and this just it's on my nerves. But anyway, that's okay. Let's go. Let's continue. So in here, but what the best way to do this instead of doing that, the best way to do this, because this becomes code dependent. I need to check to see if string is in a valid state or not. So the best thing to do is to quickly over here overload the Boolean operator to tell me if this thing. No, that's because of Halloween. It becomes boom. Okay, so boom, we do it like that. Okay, and let's add the code. Okay, so in here, now what I'm going to do over here is simply say return data being not equal to null PTR. Right? So if it's not null PTR, we are okay and we are good to go. Now in here, I can say if this, it looks like I've done something bad in here, like it was very understandable, but now it's cryptic. The thing is that if 6 months from now, you have came to the decision that that's not the only time that it's bad, I need to add conditions, you add it over there, and all the way in your code, your condition will be followed. But if you make it code dependent, then you have to go look for it every 5 seconds to see what you have. Not a good idea. So this allows easy maintenance. Okay, we're good? All right. So now we have this. Let's do our no argument constructor. Our no argument constructor says that this is empty, right? So m size, I'm going to set it to -1. Why? Oh, I cannot do -1 because it's size t. I'll set it to 0 because the other one is showing. That's fine. And I'm going to set the reason that I didn't want to set size to 0 because a string with nothing in it is size 02. You follow what I'm saying? So that I would like to set it to -1, but because SIC doesn't go negative, I'm gonna say I'm gonna just stick with that one. So in here, I'm gonna say M data, or I could change my strategy for this and say M data will be equal to new character 1. And I do it like that, which means it has only one character and it's null. So it has something, okay, but it's nothing. So I'll deal with it that way now. I don't know, every semester I do it different because I had like change of heart. Wait, so that's that. Now we're gonna do it for this one. So for this one, what I'm gonna do will be this. I'm gonna say over here, if the data exists. But data, not data. Okay. Data. If data exists, then what do? I have to do the allocation, all the good stuff, right? So do I have that one in my string? That's strcpp. Do I have an allo copy here? No, I don't have allo copy here. I thought I do. Budget. I'm going to just do it as a private property over here. So in here, I'm going to say void allo copy. So I'm going to allocate them copy from a constant character pointer data. And I'm going to copy it in there. So let's just add it over here. So in here, I'm going to say, I'm going to say, what am I going to say? I'm going to say, yeah, I'm going to say, I have a CSTR over there. So how does the CSTR deal with this thing? It's, I just need to remember how we did this. Did we create an extern in here? Where is my header file? Oh, it's just standalone functions. Yuck. Yuck. This is bad. Well, I'll use the bad one. That's fine. This is bad. Best way to do it is to actually create a class, put everything in here, and create a singleton out of that class. But we're not going to go through that now. I'll explain that later. So we'll modify that later, and I'll show it to you. So we have this, and I'm going to use it. That's fine. So now in here, I'm going to say the M. So if I want to do that, first I have to delete the M data, right? And I have to do it like an array because I'm copying it, allocate and copy. So first that has to get deleted. After that is deleted, I have to say M data is equal to null PTR. Now I'm going to say if data actually has something in it, then I'm going to say M data will be equal to, what do we set to? It's going to be set to new character. And then we have strlen of data +1, right? And then we're going to have an str copy into it. So str copy. Okay, just want to make sure that they're all good. Yes, str copy. And in this str copy of mine, I'm going to put in M data, everything in data. Right? Now, to follow my rule of having an empty thing like that, if the data over there is null, else, I'm gonna do this. So this is where I need to create a set empty function, okay? Because I copied and pasted, I have to have a set empty function. So in here, void set empty, and the set empty function essentially does that. So set empty essentially does this, copy, it pastes it over there, and we make sure that we delete before that, just in case if somebody calls it. So delete. And data, right? Do I need to set it to null now after this delete? No, because I'm doing an allocation right after, right? Okay, so now in here I can have a set empty. And in here I can have a set empty. All right, now the code is more readable. Okay, yes. Here, these two? No, because, yeah, now you can, because your set empty will take care of it. The reason that I put that null PTR is that when I was writing the if statement, I didn't know I'm going to have an else. Of course, yeah, we can. Because it's going to be either this or that, right? Quite frankly, yes, that's it. So it's either this or that. So, or if you want to make it even better, what I can do is this. Right? Why? Oh, I guess it does. Thank you. It does. You're absolutely right. You're absolutely right. I'm going to have one byte. I wish you didn't get that. And I would have later on. It would have been nice if we actually come back and try to fix it. So we learn from that. But thank you very much for pinpointed that. But anyways, the reason he's right, because if this one we're gonna have 1 byte leak. You follow? We're gonna have 1 byte leak if that happened. Or we could have added a delete over here, and that's gonna be this. So this we don't need. Yeah. Set empty deletes the data size and then allocates 1 memory, right? So then it's going to overwrite that 1 memory. We're going to have 1 memory leak, 1 byte memory leak. Good catch, good catch. Okay, so that's that. So where we were in here, so we did the allo copy, and we did over here. So in here, do I need to check for the data now? No, because the allo copy is doing it. So all I need to do over here is to say allo copy. Allo copy data, right? We good? So we're down to this point, right? So now I can actually test my program in here. Git changes. We don't want that. So now I can come over here and say include string .h. Obviously, I'm going to need sometimes they add stuff to the editor that is very bad. And the closing thing is what really bothers me. Anyways, IO stream and using namespace std. Also, since I want to have an elegant code, I'm going to quickly overload the O stream over here. So I'm going to say std O stream reference operator, and then std O stream reference OSTR, and then in here I'm going to have a const string reference right, correct? And by having this, then I'm going to have an elegant testing happening over there, because these are easy stuff I don't need to worry about. I'm just going to say over here, return s.display, write.display. And I'm going to pass the OSTR to it. So there's nothing to worry about. This is exactly what I wanted to do, right? And for some reason, it puts the curly bracket afterwards and it's killing me, but that's okay. All right. So now I can actually test this very quickly and then see what the problem is going to be. That's all I wanted to do. Oh, destructor, such a bad person. Okay, for the destructor, I need to actually wipe everything up. So that's an easy one. Delete. And that. Do I need to set the size to 0? No. Do I need to set anything to no? Oh, is that a question? I need to set it to what?
Default value of 3.
Set a default for OSTR.
Yeah,
Sure. Here, you mean?
yeah.
No, necessarily. Sure, if you want to. Yeah, if you want to use display, sure. This is just to make you happy. That's not a must.
Okay.
No, yeah, but sure.
Okay, we don't can eliminate that one.
Yeah.
Okay. Then.
But OSDR must be received. This only adds comfort. All right. Yes.
But so the last one is getting 2 arguments in the header operator. Yeah, that one. Yeah.
So this is actually the left operand. This is the right operand. I'll walk through. This is the left operand and right operand. I'm going to walk through. So in here, I'm going to say string. Oh, using namespace Seneca. And in here, I'm going to say string name is equal to Fred. And here, I'm going to say hello. Name. I think we're good. So let's walk through. Space between what? Oh, hold on. Okay, sure. When we get to it, I'm just going to do it in 2 seconds. So, yeah. So let's add the space. So our friend is happy over here. There we go. We happy? Okay. So let's, I'm just going to close all tabs. So it opens it. Save everything. And close this one. We don't need it. Breakpoints. I don't need this. Oh my goodness, seriously. Okay, this is good. Autos, let it be. And I'm going to bring this to left and bring the output to right. And let's continue. So we'll get right into our name. Constructor is called one argument constructor. That is going to, as you see, everything is nullified first. It goes to allo copy. Fred comes over here. It's deleted. We didn't need it, but it's okay. Gets the length, allocates enough memory, copies over there. M-data has Fred, gets out, comes out over here. Life is beautiful. Now, hello is printed, and after hello is printed, C out is returned. So I have C out at left, string at right. The suitable is this one. C out at left, string at right. It comes in here, calls the display of that one, which is Fred, then goes, that returns another C out, and that prints the exclamation marks, and we're out. Yes.
C out by default returns itself.
Always. That's how Cascade is happening.
Now back to my first question. When we use 2 arguments, we are defining the left and right, but when we use 1 argument, by default, one of them is the class itself.
Yeah, you cannot have an operator. We cannot have an operator with 2 arguments as a member. It just doesn't make sense. Because an operator as a member, the left one is always the owner. Therefore, you need only 1 operator for right. That's why all the 2 argument operators in this case are helper functions. Why we call them helper? Because if I wanted cout to be able to print the string, I had to go hack the class's OString class and introduce string to it so it can print it. Because I don't have access to cout, I create a helper function.
If we, let's say, remove one of the arguments, but automatically it's consider the other operand as itself, right?
No.
No?
Then it becomes a Boolean. It becomes a unary operator. As a friend or a member. If you have a friend operator,
As a member.
if you have a member, then there's got to be left one. Yeah.
Yeah.
Oh,
Yeah.
yeah. Like display.
Yeah.
Like if display was what you call it? If display was an operator, then the left side would have been string, at right side would have been cout, which is extremely wrong. But yeah. All right, so we good now to this point? Okay. Now that we have done this, I want to see what happens if I do this. Okay. Easy, right? So when I run this beautiful program of mine, nothing's wrong, no compilation. It comes, this is created, it's assigned, it says hello Fred. Again, hello Fred. So everything's good, right? Right? As soon as I get to the end, boom, crash. One more time. Let's run it. I'm going to execute it. This is what you get. Okay? It crashes at the end. Remember that. When you run a program and the program runs perfectly, and at the end, suddenly a matrix says segmentation fault, core dumped. Usually that's the reason. It's not a destructor. I'll show you what it is. So this is one case. Another case is this. If I run this, build errors. Why? It shouldn't be build errors. No, what does it say? Oh, because the program is already running. I didn't stop that. Okay. Oh God, now it's gonna hang on me. Please stop. Thank you. Okay, so one more time, Control F5. If I run this one more time, you'll see again the exact same thing happens. So let's analyze and see what are the two things that actually happened. Okay, and as you see, program is on a hang because it crashed. And it's going to take a while to stop. That's because of the crash. Okay, there we go. So this, ladies and gentlemen, is the reason. What is the reason? This is the reason. The first one was assignment, right? I assigned another one to another, right? When I assign one to another, this is what happens. So I have two files, right? I have two names in this case, strings that I had, whatever. So I had a size, one is 3, one is 7. Oh, I did not set. That's fine. Okay, so I have this and I have that, right? Now, the next line of the program says, let's set B to A. So when you say set B to A, what does the compiler see? Two classes, identical, right? It copies everything from A over B. So it takes the address that you have in MData, puts it on this one, takes the 7 and overwrites the 3, right? So as a result, this is what you see. This memory is lost. And when the constructor takes effect, the first constructor comes through, it destroys the first one, right? We have the memory leak, that's set aside. The first constructor deletes that one, the program is ending. Now the second constructor wants to delete this one. What happens? Crash. Because it's trying to delete something that is not there. That's assignment. Yes. Yeah, the memory leak you don't know. The memory leak is one of, again, remember I told you like
That's the million. That's the 1 million. Plus the million.
it's something, yeah. But the thing is that you keep this thing leaving in this. So if you run this program 50,000 times, this is going to grow up. And that's when you're going to see your mouse is not moving properly anymore and everything is slow. You reboot the computer, everything fast. Yes, that's the reason. I always mention in class that like all the modems that you have, after a while it doesn't work anymore. You take it out and you put it back in, it works. Say, you call Rogers and they say, unplug it and plug it back in. That's what they want you to do. It has a leak. It's screwing things up. They want you to remove. So it restarts and then after a month, it's going to be the same problem. We go down to this, yeah. No, the crash. The crash is the action that it actually wants to delete that doesn't exist. Yes. It's the moment of deletion that causes the crash.
It's the shallow copy. It's trying to delete the first one, right? The actual.
I never taught anything about shallow and deep copy yet. This is the subject of today. Okay. Okay. So that's that. Okay. Now the other one was the copying that we have done. So you have one, right? And you want to create one from another. So again, the compiler sees only one thing. It builds the other one out of the other one. This time, this one doesn't have memory leak, but they are still both pointing at the same shared of dynamic memory. And when one is gone, the other one will crash. Okay? So when you look at copying, I'm going to bring the copying again. This action, ladies and gentlemen, there's no lady here? No? Or whoever's watching at home. This action over here is called shallow copying. Shallow copy is whatever is within the scope of the class that gets copied automatically to the next one. What is missing here is deep copying, which is this one. So when action of copying is happening, you have to tell the compiler, hey, you don't do the copy, I'll do it. Which means you're going to measure the memory. So this is what you're going to do. So for the assignment, for example, let me see which one I'll bring one first. I'll bring the copying first. So the good way of copying is that you take a look at what's happening over here. So when the action of copying is happening, you have to actually measure and see what is the size of the other one. Allocate the memory. Then after allocating the memory, you have to copy everything you had in the other one into this one. After the copying happens, then you shallow copy the 7. So because you took over the copying, even shallow copy won't happen. You have to do the deep copy. You have to take care of the shallow copy. And then after it's done, you have 2 standalone objects. One get deleted, beautiful, and second one get deleted. Life is fantastic. This is called copy constructor. So you had a constructor. You have to now write a constructor that takes care of copying. What is the definition of a copy constructor? It's a one-argument constructor that the argument is an object of the same class. We have to see how we are editing that, how we are implementing that. And the other one is the assignment. So in this one, when we are actually having the assignment, it becomes a bit more trickier. Why? Because when you are doing a copy constructor, there is no already existing data. You are creating a fresh class. You don't need to worry about already existing data. But now, when the assignment is about to happen, You have to first delete the old one because you don't want to have any leak. After deleting the old one, you have to do the process of copying again. So you have to do the new data, bringing everything in, and do the shallow copy. And now you have everything. And then when it's gone, we're going to have the smiley face coming up. Are we good? Let's write it. How do we write it? It's extremely easy. I'm going to start with the copy constructor. So with the copy constructor, where is it? Come on, you can do it. Let's see, I can't open view code. No. One of these says, okay, go to, that's the one. Okay. So what is the signature of the copy constructor? It's a string. Okay. That, first of all, you don't want to change what you are copying, right? No. So it has to be constant. Then string. And in here, I'm going to say other. Now, this is wrong. Why is this thing wrong if I don't make it a reference? Because if you do this, the action of copy constructor requires for this to get copied because you're passing by value. So you are implementing the copy inside, so like chicken and the egg type of a thing. You shouldn't do that. That's why you have to make sure this is a reference. And now we have a correct signature. For the assignment, you know already how to overload the assignment operator. So I'm going to say I'm going to receive a string. It's going to be operator equal. Exactly the same thing like the other one. String, reference, other. Now let's implement the easy one first. So now in here, it's a fresh class. And I know everything is null already because I did it in the at the top over here, right? Let me split the window. I don't know what to do with these. Oh, there's maybe setup does it, huh? Toggle multiple, no. Show tabs, come on. Wait, maybe options? Toggle multiple, there should be.
It is the multiple rows.
Do you have a text editor options?
Yeah, I have text editor options. There we go.
All languages? Scroll bars?
No, scroll bar are these, my friend.
No,
Where do you see that? This one? 3 marks for final exam. Oh, I'm a happy man now. Sorry. Seriously, I was like, it was going on my nerves, the damn thing. I don't know who's like somebody goes in a meeting and says, what if we put a big scroll bar on the left? Like, which idiot thinks of that? Seriously, we already have it here. Why do we need? Anyways, sometimes people, anyways. All right, so I have everything null already. So all I need to do is, what do? Oh, it's easy. I'm going to say allo copy. Actually, my allo copy is not written right. My allo copy is not written right. I'll show you. I copied over here, but I forgot to set the size. Right?
Yeah.
Yeah. So what I needed to do over here is to say M size is set to that. Is set to that. That's better.
Where the null terminated.
No, I'm a bad person. You don't let me have some bugs in here, for heaven's sake. We should put some tape on it. Yeah, so so anyway, so I'm setting the size and I'm doing, and why is it giving me that now?
Missing one parenthesis.
Missing one
One
parenthesis.
parenthesis.
Stupid compiler. Okay.
End of the one.
Thank you. Okay, so, all right, so that's that. And set empty is setting the size, isn't it? It is. Okay, so that's good. So now I'm size is set. Now I can do allo copy. Okay, so where's the thing? Where am I? I was here, right? So allo copy, other dot m data. I could have set m size is equal to n yada yada yada, but I don't need to. It's gonna do it anyway, right? Right? So it's doing the auto copy. It's done. Now, so now let's check and see if the copy construction fails or not. This is with copy construction that failed, right? So I'm gonna go F10. It's gonna come over here. Name is created, and as you see, it has Fred in it. Now it goes to name 2. Assignment at the moment of creation is a call to one argument constructor. And because the one argument is object of the same type, it goes to the copy constructor. Now in the copy constructor, when it comes in, it first nullifies everything. That's the rule for it, right? Then it comes over here and does auto copy. So it comes over here, deletes the current data, which is now needed. We don't care, right? Then it comes over here and does the allocation, and size becomes 4 like the other one, copies the data, goes out, and now we have ourselves 2 things. So it comes over here, yada yada, goes to the first destructor, deletes it gracefully, goes to the second destructor, deletes it gracefully, and we're good. That's copy constructor. Now, the problem is that we wrote the code a little too intelligently. So when I actually want to come over here and do this one, I can simply say allo copy 2. Oh. And I'm not going to have memory leak, I think. Why? Because in allo copy, I'm deleting the old data. But that's the only thing, because we wrote the allo copy and allo copy is deleting beforehand, we are clear to go. That works too. But if you are manually doing this, remember, in assignment operator, you must delete the old data. Because our allo copy is doing it, I don't need to worry about it. But there is one thing that I need to worry about, and that's dealing with crazy people. Because there is some numbnuts out there that is going to do this. Right? That's going to screw everything up, because when you are copying, you're going to delete, and after deleting, it's going to hit the fan, right? So for that, I have to make sure I'm not copying myself. For copy constructor, it's impossible, because you are building a new object out of another one. You cannot copy something out of itself. But for assignment operator, you can. Now it's either a numbnuts or is somebody who doesn't know what they are doing, because they create a reference and they don't know that they are the same. You follow? Because they don't know. They think they are the same, they are 2 different things, but they're references of the same place. Okay, for this, how can I find out if something is copying itself? It's extremely simple. Just see if they are at the same location in memory. So how do I know what is the address of me? It's this, right? So if I say if this is not equal to address of the other, do the copying. Otherwise, do nothing. Right? Because it's already there. If you don't need to copy it. Believe it or not, I don't know what's going on in OOP244. In OOP345, Many people are losing mark on this because they write crazy stuff like target of this is equal to not other, or they write, put the ampersand after this, and I have no idea where they are coming from. But I see many people doing that. Please don't be those people. Yes.
We are putting name in name two, we are copying it. Which one is being used? The operator equal sign, or is it the constructor which we just create?
Which one? You're talking about this line?
Yes. Yes.
For this line?
Yes.
Okay. When I say something, I mean it. Listen to it. Assignment at the moment of creation is a call to one argument constructor. It has nothing to do with assignment operator. This is not assignment operator. This is not assignment. This is exactly the same thing as writing string name to name. Line, I don't have the line number. Somebody find out how to line number. Bring up the line. Yeah, so this line and this line, these two lines are identical. Actually, let me write all the lines that you want to see. This line, and this line. These four lines are exactly the same. No difference. Again, somebody sat over there. When I do a comment, close it immediately. Okay, there we go. So these four lines are exactly the same. Okay? Huh?
So isn't that confusing?
No, it's not, because it's at the moment of creation. At the moment of creation, never an operator is called, ever. It is creation, and creation means constructor. Never, ever at the moment of creation, you can call an operator. You are creating something. It's as easy as that. But of course, if I write it over here now, so let me actually create a third one. So in here, I'm going to call it, oh, son of a. Okay, so 3. Okay, now I have name 3. So I have 3 names, right? And in here, I'm going to say name 3 is set to name.
Because now we don't have the keyword string, we're not creating.
Yes, it's operator. So this is an operator, this is an operator, and yada, yada, yada. And let's go to name, let's print name 3 over here too. And then we're going to walk through. There's one thing that is missing, which is this guy. Why nobody's saying anything? I put that thing in a copy constructor. Shame on you. I put that code in a copy constructor instead of assignment operator. Nobody's saying anything. You're the teacher. You're supposed to see. I know, that's what you were thinking, wasn't it? Okay. So yeah, so there's one thing missing. That is the operator's return. It should return the reference of the current object, so the story can continue. So always at the end, you have return this. Okay, so because of this fact, you can actually do this. Because it's returning the other one. It keeps going like that. Okay, you can actually have cascading stuff happen. So let's walk through. I'm going to start. And before we continue, I'm going to mention this is called rule of 3. Remember that. Rule of 3 means copy construction, copy assignment, and destruction. Whenever you have a class that it has data outside of its scope, you must have these three. Otherwise, your program is going to crash. Either you must have it or you must deny it. Like if you want to say, I want to have a string and I do not want the string to be copied, you can. If you do this, it means string is not allowed to get copied. You write delete in front of it. It means that is forbidden. So that is still implementation of rule of three. You may create a class and you don't want the class to be copied, like cout. You don't want them to be able to put a cout, create a copy of cout. It's not supposed to be copied. That copy constructor is deleted. That copy assignment is deleted. You are not deleting. You are not allowed to do it. Got it? So remember, this is to deny it. But it's still rule of three. We good? Okay?
So assign it and then the operator and then destruct it. Reboot.
Copy, assign, delete.
No.
Copy, assign, destroy. In OOP244, it becomes rule of five. You need two. Yeah, but you're going to learn two more things. Oh, it's move. But move. No, it's two moves. Move constructor and move assignment. Yeah. Move constructor essentially means, now that you mentioned it, it means I have a cup of coffee. He has a cup of coffee. I don't need to rebuild the whole thing. I can just say, pour the coffee here. So pours the coffee, that becomes empty. That's moving. So that's the next thing you're going. I don't know why we are not teaching it now because it's so simple. It's actually much simpler than this. But anyways, so now let's walk through this. So it comes, this is a constructor. This is copy constructor. So goes to copy constructor and everything is good. So copying happens, comes out. This is again copy constructor. I'm not going to bother you with that. This is just the default constructor. That's fine. Now in here, I'm creating a reference. Nothing happens. In here, I am copying something to itself. So when it actually comes in here, it says, am I the other one? It says yes. So ignore it. Don't do anything. Jumps up. Now in here, I'm copying the first one. So the left one happens. More in here, that is this, has nothing. Oh, it has Fred in it. How does it have Fred in it? I don't. Oh, no, it's probably the right one that is happening. Yeah, it's name 3 that is happening, probably. Anyways, so that's that. Yeah, and then afterwards the other. So it comes over here. It's not the same. Auto copy happens, goes out, and then that goes go to the next one. And now this is the one that is blank, right? So that happens too. And now we have 3 things in our hand, and they are all Fred over here. And when the destructor gets called, every single one of them are destroyed correctly with no problem. In reverse order. Are we good? Okay. The thing is that I did not demonstrate shallow copy over here. That auto copy, I shouldn't have written it. We should have had done this manually. So that's your practice. Go home, remove auto copy, and repeat the code. Don't worry about it. It's good for your health. Okay. So your test, your assignment will be take this home, this exact same thing, and start, what should we call it? Start writing it manually and test it to see if everything works properly or not. Just take the auto copy out and do everything manually. Okay? And all the slides are going to be there when I get home. I don't know how can I actually put it up without, let me see if I can actually do it here because I don't have my SSH key on this computer, so I don't know. But by the way, lecture is over. That's it. That was today's thing. Pardon me? No, I'm not taking attendance anymore. The attendance was applied automatically during midterm because the way that the midterm went, it was like up and down, like, so people will know. Yeah, that was sad, but Anyway, so let me just give me a second. Let me try and see if I can actually do the thing over here. So CD or that NAA notes. Okay, git add everything, git commit dash what is the thing we have? It's 11 November 4th. Let's see if oh 10. I got it with SSH. I'm hoping that it's going to ask for my user ID and password. Now, fingers crossed, git push. I know. Oh, signing with your browser. Yay. Let's see if it's going to work. For that. Oh, actually signing with Google is easier. Actually, fingers crossed. I think it's doing something. Continue. Sure. Okay. Okay, didn't work. Please complete authentication in your browser. Let me do it one more time. Control C. Sign in with the code. That is better. Visit the URL below, sign in. Man, they have such a this browser device is reporting partial passkey. Okay. Authenticator app. Okay. 77235. Continue.
Do you have anything planned for the rest of us?
No, I'm trying to log into GitHub and you can go, and I'm going to suffer trying to put this thing in. Okay. That's a good one. Let me just stop the recording and be done with it. I'm just trying to submit this to the thing. Have a good one. No, it's a lecture to the bone, so you have to be there. So, and meeting and